Caterpillar introduced its 3400 series diesel engines in 1973 with the 3406. Subsequent models followed during the next 3 years. This engine family was designed, developed, and engineered to provide a superior product that could meet worldwide customer needs for power in the 250 to 750 horsepower range. Stringent design objectives for Caterpillar 3400 series engines included durability, application flexibility, fuel efficiency, ease of maintenance and repair, performance and reliability, all directed to lowering owning and operating costs. To achieve these objectives, Caterpillar made a major commitment to the production of this engine family. Quality castings for such items as blocks, cylinder heads, and liners were assured through an expansion of Caterpillar's foundry at Mapleton, Illinois. This expansion included both capacity and technology. During the same time frame, a new manufacturing facility was opened to produce the 3400 series. Building BB incorporates some of the most advanced engine manufacturing technology available. Blocks, heads, crankshafts, and other components are machined to exact specifications on automatic transfer lines. Built-in electronic gauging devices are utilized to control quality and compensate for cutting tool wear. Computerized testing of every engine provides uniform performance. Today, the 3400 series engines continue to offer users a durable, dependable power package for many of the world's toughest applications: marine, main propulsion and auxiliary power; agriculture, ag tractors, forage harvesters, and irrigation equipment; material handling, air compressors, compactors, drills, dredges, and off-highway trucks; electric power generation, prime and standby power; petroleum, land-based and offshore operations; truck, on-highway heavy-duty vehicles. The 3400 series consists of an inline six-cylinder, the 3406, with a 5.4-inch bore and a 6.5-inch stroke. With its big displacement of 893 cubic inches and excellent weight-to-horsepower ratio, the 3406 is fast becoming a very popular diesel engine in its horsepower class. The 3408 is a V8 configuration with a 5.4-inch bore and 6-inch stroke and 1,099 cubic inch displacement. Its unique 65-degree V-block angle allows installation in narrow envelopes usually reserved for inline six-cylinders. By offsetting the crankshaft journals 25 degrees relative to the crankshaft centerline, evenly balanced 90-degree firing intervals are created. The offset 3408 crankshaft is unique to the heavy-duty engine manufacturing business. The 3412 is a V12 configuration with a 5.4-inch bore, 6-inch stroke, and 1,649 cubic inch displacement. Since its introduction, the 3412 has become the standard power unit for many high load factor applications. Structurally, any engine depends on the strength of the block. For its 3400 series engines, Caterpillar developed a cast iron alloy block with an average tensile strength of 28,000 pounds per square inch that exhibits superior durability in high load factor operations. The block is also stress relieved. This process alleviates residual forces created when the casting is cooled. As a result, the metallurgical structure of the block stabilizes, avoiding dimensional changes that can occur due to normal heat loads in an engine as it operates. Increased resistance to stress cracking is also a feature of this process. Block strength and dimensional stability are readily apparent at overhaul time. Crankshaft, camshaft, and cylinder liner bore alignment problems are very rare. The 3400 series cylinder head is a solid, one-piece design that resists the twisting and dynamic flexing of an engine, which can lead to misalignment and relative motion between internal components. On 3408 and 3412 blocks, an intake manifold is cast integrally in the V. This allows cylinder head removal without disassembling the intake manifold. Located between the head and block is a steel spacer plate. It eliminates counter bores and the potential for crackings, adding strength and rigidity to the head block assembly. Another means of adding rigidity to 3400 series engines is the head bolt pattern. 6 bolts are used around each cylinder, with 2 of the 6 adjoining each cylinder. Once secured to the block, the head and spacer plate help make the whole structure very solid and extremely rigid, which provides less engine vibration, reduced downtime, improved head gasket life through the elimination of head-to-block movement, increased head life. 3400 series engines utilize an efficient 4-valve design, 2 intake and 2 exhaust per cylinder, for maximum breathing, which aids combustion and reduces pumping losses. Hardened steel valve stems resist heat and corrosion. Valves are faced with a cobalt-based chrome tungsten alloy, which helps retain hardness at high operating temperatures. When valve seats become worn, replaceable valve seat inserts provide easy maintenance. Intake inserts are a stainless steel alloy and exhaust inserts are a nickel-based alloy. Each valve has a rotator which increments the valve face 3 degrees relative to the valve seat during one complete cycle of the engine. This assures uniform wear for longer valve life and helps prevent burned valves. The 3400 series crankshaft is a carbon steel forging heat-treated by a patented total hardening process which provides high strength and outstanding wear resistance. Total hardening gives the crankshaft a hard surface Rockwell C of 48 to 55 to a depth of 375 thousandths of an inch. This depth of hardness provides excellent rebuildability characteristics at overhaul time. Because the crankshaft is hardened over its entire length, stress risers typically found at boundaries between hard and soft metal are eliminated. Thus, total hardening provides a durable crankshaft less susceptible to cracking. Steel wear sleeves are installed over the ends of the crankshaft. A Teflon oil seal presses against the wear sleeve rather than the crankshaft. This prevents wearing a groove in the crankshaft hub and eliminates the expense of regrinding the hub. Simply replacing the oil seals and wear sleeves during a scheduled maintenance period minimizes downtime and overhaul costs. 3400 series engines utilize one camshaft for valve train operation and another camshaft for fuel injection timing. The engine camshaft is a drop-forged hardened steel alloy. All Caterpillar engines use steel-backed aluminum alloy bearings with a lead tin overlay. The aluminum alloy bearing surface has the strength necessary to withstand heavy shock loads during crankshaft rotation, is soft enough to absorb small particles of debris and adapt to normal wear of the journal profile, and is compatible with a steel crankshaft journal. Aluminum is also an excellent conductor of heat. This characteristic allows frictional heat to be distributed evenly, preventing hot spots. Aluminum is also highly resistant to corrosion caused by acids developed in the lube oil. The lead tin overlay provides additional bearing protection when lubrication is minimal during engine starts. Caterpillar uses a forged boron steel connecting rod that is hardened and shot peened for stress relief. Tapered end design provides more area for wrist pin and pin bore contact during the power stroke, which results in extra strength and durability of the piston and rod assembly. Pistons are critical to the design life and overall performance of an engine. The Caterpillar 3400 series 3-ring piston is an aluminum alloy casting with a cast-in nickel iron band for the compression rings. This band provides long-wearing grooves for the Keystone design compression rings. The 3-ring design, while providing excellent oil control, reduces friction, which decreases heat buildup and results in a long piston, ring, and liner service life. By reducing wear, these components can be reused at overhaul, further reducing maintenance costs. For strength and durability, piston rings are nodular iron. The oil and intermediate rings are chrome-coated, while the top ring is plasma-coated. Both coatings provide excellent wear and scuff-resistant properties. The 3400 series liner is a cast iron alloy that exhibits excellent strength and durability. To aid wear life, the inner surface of the liner is induction hardened. And to provide good oil dispersion, this same surface is cross-hatched through a honing process. Another process to aid liner life is the rolling and burnishing of the liner flange, a high-stress area susceptible to cracking. At overhaul, Caterpillar liners are frequently reused, thereby offering the user superior value for his investment. 3400 series engines utilize a direct injection multiple pump fuel system. It is factory calibrated and features individual scroll-type injection pumps and capsule-type injection valves, a proven combination used in Caterpillar diesel engines for many years. The complete unit, except for the injection valves, is externally mounted for easy access and servicing. The injection valves feature a no-dribble design that helps meet mandated emission levels. To aid injection valve life, the tips are of a hardened steel. Standard on all 3400 series engines is the automatic timing advance unit. Located on the front of the fuel camshaft and driven through the timing gears, this unit provides speed-sensitive timing to optimize engine performance over the entire operating range. The gear-type fuel transfer pump has a check valve and a bypass valve. The check valve controls fuel pressure. The bypass valve permits fuel to go around, bypass the transfer pump when the priming pump is in operation. The fuel transfer pump features an ability to raise fuel from supply tanks located lower than the engine. This allows fuel supply tanks to be remotely mounted depending on application and user needs. The engine-mounted fuel priming pump allows quick system priming after bleeding air from fuel lines. The system is designed to be self-airing. This allows the installation of dry fuel filters and easy restarting should the engine run out of fuel. All 3400 series engines are equipped standard with a full-range, hydraulically assisted governor. The governor flyweights responding to load variations cause the governor control valve to move, which in turn causes the fuel pump rack to move, either increasing or decreasing the amount of fuel to the engine. Thus, the governor provides total speed control over the entire operating range of the engine. Also available on generator set configurations is a dashpot type hydromechanical governor, which provides more precise governor regulation. Woodward PSG governors are available for marine, industrial, and generator set configurations. They operate as an isochronous or droop governor and use pressurized oil or hydromechanical regulation. Engine speed is monitored by a magnetic sensing unit mounted on the front timing gear housing. The Woodward 2301 electronic governor is available on generator set configurations of 3400 series engines. This system is equipped for parallel or non-parallel applications and is capable of droop or isochronous operation. The 2301 control unit is 24 to 30 volts DC powered and is remote mounted. The engine-mounted EG3P actuator, which responds to electrical signals from the governor, controls the fuel rack position. Engine shutdown is accomplished by interrupting the electrical signals between the governor and the actuator. To meet varied user requirements, Caterpillar offers a diverse line of attachments for 3400 series engines. These attachments allow the user to match the proper components to the specific application, thereby enhancing product value. All Caterpillar designed and tested attachments have the same quality features of Caterpillar engines. On 3400 series truck engines, a brake-saver hydraulic retarder is available to provide a means of controlling the speed of the truck while descending long grades. Also available as attachments, but only for 3406 truck engines, are the Jake brake, which retards through automatic controls that stop fuel injection, and the Williams Blue Ox, an exhaust brake, which is basically a valve fitted to the exhaust pipe between the manifold and the muffler. The primary advantage of compression and exhaust brakes is their ability to be retrofitted. They also have slight weight and significant cost advantages. However, because of the brake saver's high retarding capability and its quality features, it is a long-term investment with more payback opportunity than most other auxiliary braking systems. This chart compares auxiliary braking capacity at the drive wheels. 3400 series engines employ three main types of cooling systems. Depending on the application, either radiator, heat exchanger, or keel-cooled systems are available. On all 3400 series engines, a gear-driven water pump divides the coolant at the base of the pump housing, sending approximately 75% to the oil cooler and 25% to the aftercooler, if so equipped. From the oil cooler, coolant is pumped into the block and then through a series of internal passages where it is directed around the entire length of the cylinder liners. All temperature regulators on 3400 series engines with expansion tanks are set at the factory to begin opening when the jacket water temperature reaches 180 degrees Fahrenheit. Various temperature settings are available to coordinate with other cooling componentry such as shutdown louvers and fan shutters in truck and industrial applications. Three types of engine protection systems are offered as attachments on 3400 series engines: mechanical, electrical, or electromechanical. All three systems provide oil pressure and water temperature protection. Only the electrical system provides overspeed and air inlet shutoff, in addition to oil pressure and water temperature protection. Electrical shutoff includes an electronic switch, a pressure delay switch, and solenoid shutoffs for air inlet. Also available, except on truck engine configurations, is a manual shutdown lever located near the governor. The lever allows an operator to manually override governor control of the engine by moving the fuel rack to the full shutoff position. This lever is not compatible with mechanical shutoff. Truck engines may have 12-volt electric solenoid shutoffs or a truck manufacturer's total system. Two types of starting systems are available attachments on 3400 series engines: air start and electric start. The flywheel housings on all 3400 series except the 3406 truck engine have two starting pads for the mounting of electric or air starting motors on either side. The 3406 truck engine has only one starting location located on the left-hand side. Depending on arrangement, SAE number 1 or SAE number 0 flywheel housings are available. Flexible plate couplings and mounting hardware for use with generators. Flywheel guards as well as other attachment protection. Caterpillar SR4 generators are available for use as prime and standby power with kilowatt ratings ranging from 145 to 600. They feature tropicalization protection for humid environments. Parallel capability is standard. Steady state voltage regulation plus or minus 1% from no load to full load. Low telephone influence factors. Responsive volts to hertz regulation. Control panel, either engine, wall, or floor standing mounted available. Standard instrument panel includes fuel pressure gauge, oil pressure gauge, and water temperature gauge. Premium instrument panels with either 6, 7, 8, or 9 gauges. Gauging options include tachometer, oil pressure, oil temperature, fuel pressure, exhaust, pyrometers, water temperature, marine transmission oil pressure, and air inlet temperature. Remote-mounted pilot house instrument panels available. Electronic oil pressure and water temperature gauges, 24 and 32 volts DC. Developing a quality engine line is only part of the value picture perceived by the user. Caterpillar's long tradition of supporting its products with superb service and parts availability provide the user with a consistently good performing power package. With more than 1,000 sales, service, and parts facilities in over 140 countries, this network provides users with service and support before, during, and after purchase. The Caterpillar dealer is there to offer his Cat Plus services. These services and the Caterpillar backup support reflect the commitment that Caterpillar has to the diesel engine business. The 3400 series engines of today offer well-designed and quality-built power packages to meet user needs worldwide. The value of a user's investment in Cat diesel power can be substantiated through economical performance and long service life.
In trucks of every description, Caterpillar diesel engines are moving America. With over half a century's worth of experience building diesels and nearly 400,000 truck engines put into service since 1960, Cat is an industry veteran. Today, as an established leader at the vanguard of diesel technology, Caterpillar builds 31 different engine configurations from 165 to 450 horsepower specifically for trucks. Emphasizing Caterpillar's commitment to the trucking industry is David Gould, Vice President of Caterpillar Tractor Company and General Manager of the Engine Division.
This is part of our engine manufacturing facility at Mossville, Illinois. With new plants at Lafayette, Indiana and Pontiac, Illinois, Caterpillar now has 10 million square feet of factory space devoted to the production of diesel engines. About 25% of our corporate assets are committed to the engine business, and it's a commitment we take seriously. For example, the 3208 Economy 2000, the 3306, or the 3406B represent the very latest in diesel engine technology. Superior value is what it's all about with Caterpillar truck engines. Superior value measured in terms of the lowest cost per operating mile. At Caterpillar, we call it Economy Plus.
Economy Plus begins at drafting boards and test cells, but encompasses much more. Everything from initial design to after-sales support. For mid-range and heavy-duty diesel truck engines, Economy Plus means a design that is thoroughly tested. With our reputation riding on durability, reliability, and fuel economy, we test prototypes in the laboratory under severe conditions so you don't experience on-the-road problems. Trim weight, compact size, large displacement, and customer-matched ratings mean that Cat engines offer excellent value across every engine family. Cat engines begin with superior quality castings poured in our Mapleton foundry. Computer-controlled induction furnaces guarantee consistently high metallurgical quality. It's the only way to provide that extra measure of value. With a goal of extended engine life, all Cat truck engines have a totally hardened crankshaft, hardened across its entire surface, not just at journal and fillet areas. Caterpillar heavy-duty diesels feature cylinder liners that are induction hardened on their internal surface. Aluminum alloy long-life pistons use a proven ring design that reduces friction. Connecting rods are forged boron steel for extra strength. This kind of quality goes into every Cat truck engine. Since its introduction in 1973, the Caterpillar 3406 has been recognized by the trucking industry as the quality heavy-duty diesel. Billions of highway miles as proof, the 3406 is an engine that has stood the test of time.
Improving an excellent engine is a challenge we enjoy. The second generation 3406, the 3406B, is an engine designed to take you and Caterpillar into the next decade. Improvements in the fuel system, the camshaft, and the turbocharger enhance fuel economy and performance. It's the same design engine, but with important economy plus features that are designed to be of great value to the truck user.
The 3406B is available in a variety of economy ratings from 285 to 400 horsepower at 1600 and 1800 RPM. These ratings offer an effective operating range with high torque rise that meets virtually any on-highway operator need. Where fuel economy is paramount, the 1600 RPM ratings, a concept pioneered by Caterpillar, offers far better performance than any competitive engine. Vocational ratings from 310 to 400 horsepower at 2100 RPM are also available for specialty applications like logging, mining, and construction. These ratings offer a wide operating range and very high torque rise for maximum flexibility. In addition to impressive performance characteristics, basic fuel efficiency has been improved by 3 to 5%. At a time when the industry works hard to squeeze out mileage improvements of even 1%, imagine the fuel savings from an entire fleet of 3406B. One of the features that help make these performance and economy improvements possible is a new fuel system. Tested for millions of cycles and developed to handle operating pressures in the 15,000 psi range, this design ensures fast, accurate, and efficient injection. The entire fuel system is adjustment-free. It is intended to last the life of the engine, not just to overhaul. Because of the large fuel gallery, it's not necessary to use a priming pump to restart after fuel filter changes. Pressure side filtration keeps air from entering the system, which in turn improves cold starting and low idle lug. The new fuel system meets more stringent emission requirements without compromising performance or economy. Caterpillar's full-range governor maintains nearly constant speed over rolling terrain, reduces gear shifts and accelerator changes, resulting in improved trip times and less driver fatigue. These fuel system improvements have been combined with new high-efficiency turbochargers, which are precision-matched to engine horsepower output. These low-inertia devices react instantaneously to load demand and they automatically compensate to maintain combustion air density as altitude increases. An aftercooler increases air density even further to improve fuel efficiency. A new high-lift camshaft and refined valve train ensure more efficient breathing. Valve rotators assure tighter uniform seating to help extend valve life. It is all of these features that add up to make the 3406B another Economy Plus from Caterpillar. When you buy a new 3406B, you are buying more than just a reliable, durable, and fuel-efficient diesel engine. You also get the most extensive product support system in the industry. There are over 2,200 authorized Caterpillar parts and service outlets in North America, backed by 16 computer-linked parts distribution facilities. But if the parts you need are not in stock, CAT guarantees availability. You get your parts in 48 hours or less, or you get them free. No other engine manufacturer has made this promise. Caterpillar truck engines are completely rebuildable. To save money and time, worn components can be exchanged for CAT remanufactured or dealer rebuilt components on an over-the-counter basis. A CAT program called Scheduled Oil Sampling, where crankcase oil is analyzed on a regular basis, lets you accurately measure engine wear. This makes it possible to schedule downtime rather than schedule around it. To help engine owners get the lowest cost per mile and the greatest value per dollar spent, CAT encourages proper maintenance. It offers a variety of flat-rate repair options. These include lower-end, in-frame or out-of-frame overhauls, as well as CAT remanufactured short blocks or complete engines. You choose the repair option that best suits your operational requirements. Once in the shop, your engine will be serviced by mechanics who have been trained and certified through Caterpillar service qualification programs. For fleet owners, many CAT dealers offer troubleshooting and routine maintenance training programs for mechanics. Another exclusive CAT program is the Power Analysis Report, called PAR. At participating dealer power centers, trucks are tested on computer-linked chassis dynamometers. Unlike standard dynamometer testing, PAR compares engine performance to original specifications over the entire operating range. PAR can help improve economy and performance by pinpointing engine problems. Even before you make a decision on what engine, transmission, and rear axle combination is best for your application, CAT is ready to help with another Economy Plus program. To assist buyers in the complex specification process and to ensure proper application, CAT has developed a truck performance analysis computer program. This simulation will provide users with expected vehicle performance from a given set of specifications over many major North American routes. With the TPA program, users can actually try a variety of engines and driveline combinations before they buy. Once in operation, Caterpillar driver training programs can help ensure efficient driving techniques. These are the kinds of programs that stand behind every Caterpillar truck engine and make each 3406B more than just a quality diesel. It's a whole different approach to trucking. It's Caterpillar Economy Plus.
We've never made the cheapest engines. We've always made the best. Our reputation in the trucking industry, a reputation based on selling premium quality engines and supporting them throughout their useful life, is our greatest asset. Traditional Caterpillar durability, reliability, and serviceability, plus an added measure of performance and economy, make the 3406B the engine for today and tomorrow. Best of all, it's backed by the biggest name in diesel power, Caterpillar.